Hi everybody. In this video, we are going to discuss about how to access two-dimensional arrays using pointer. So, let us consider a matrix, a two-dimensional matrix, mat of 3, 4, and this is my first row, this is my second row, this is my third row. So, 3 rows and 4 columns. So this is how it gets placed here. So we'll have the first row, 1, 2, 3, 4, second row, and a third row. And always the index starts from 0. So what is mat of 0, 0? 0, 0 is going to be 1. Right? So you have 3 rows, 0 to 2 index, 4 columns, 0 to 3 index. That's how your matrix is stored. Assume that the first element or your matrix is stored in the location 1000. That is, the starting address of your matrix is 1000 and the size of an integer is 2 bytes if this is the case. So my starting address of the memory location of my matrix is 1000 and the integer occupies 2 bytes of memory space. So in that case, we can understand this is how my memory will be, right? So first row, then the second row, then the third row. Arrays will be stored continuously in your memory space. And now, if the starting address is 1000 and if the integer occupies 2 bytes, in the 1002 location, the second element will be stored. The 1004, the third element will be stored and so on. Right? So you can understand here, it's very easy to access the array using pointers because arrays are stored in continuous locations. So if we know the first address, the starting address, we'll easily know all the remaining addresses. Okay. So that's the very basic idea of accessing arrays using pointer. Its advantage is this. Okay. Right. So let me create a pointer variable, PTR, which is going to point to an integer. I'm storing the address of mat of 0, 0. So 0, 0 is the first element of your matrix. And I'm storing that address, that's the starting address of my matrix, to PTR. So PTR is going to point to the starting address of my two-dimensional array. Okay, so PTR is a pointer which is going to point to the starting address of my two-dimensional array mat. Okay, so now how do we access using a pointer? This is a very simple program. So the same thing, I've created a mat with all these elements. This is how we create a two-dimensional array, right? So first row, there are different ways. This is one of the way. The first row within braces, the second row within the braces, the third row within braces, and together enclosed within a braces. Okay, so this is my first row, second row, third row. Okay, fine. Now we can see from this, there are 3 rows, 4 columns. So I've initialized R to 3, C to 4, and I and J for my looping variable. Okay, then I'm creating a pointer variable which is going to point to the starting address of my matrix. Okay, so let us see how do we access the matrix using a pointer. So my I loop is my row loop, that is I equal to 0 to R. Okay, J is my column loop, J equal to 0 to C. Fine. Now what am I going to print? I'm going to print the matrix elements, the matrix values using PTR. Okay. Okay. The first time I enter I equal to 0. Right? When I equal to 0, J varies from 0 to 4. That is 0, 1, 2, 3. Because C is 4, right? So when I equal to 0, J varies from 0 to 4. Okay. So I equal to 0 right now. Now what happens here? PTR is going to be the starting address of my matrix. I into C, 0. Okay, whatever my column, that's not a problem. I is 0. So that returns 0. Plus J. So J is 0. So PTR plus 0 plus 0. That is PTR. the first address. So it prints the value present in PTR. So that's going to be 1. Fine. Then I equal to 0, j is 1. So what happens here? PTR, again, this will become 0 because I is 0, right? So PTR plus 1. You know that when you perform arithmetic operation on an address, it increments by the size of the data type. Here we are assuming integer is 2 bytes. When I say PTR plus 1, PTR is the starting address. As we saw in the previous slide, if PTR is going to be 1000, and if the integer size is 2, so PTR plus 1 will be 1002. Okay, so PTR is 1000 plus 1, so 1002. It prints the value at 1002. Then j becomes 2. So I is 0 now. So PTR plus 2. So 1004. Value at 1004. 3. Then j becomes 3. PTR plus 3. 1006. So value at 1006. Then j becomes 4. It comes out of the j loop. Again, goes back to I. I becomes 1. Okay, so when I is equal to 1, again, it comes inside. J varies from 0 to 4. 0, 1, 2, 3. Let us see. PTR. So C is 4, right? So 1 into 4. So we'll have to move 8 bytes. Why? Because I'm going to print the second row. So I will have to move from the first row to second row. So PTR is the starting address. From there on, I will have to move to 4 integers. Okay, only then I'll come to the second row. Okay, so J is for the column. So I into C is for the row. Okay, I is 1. I'll have to move 4 numbers. So 1 into 4. Okay, so PTR plus 4 plus 0. Okay, so what happens? PTR is 1000 in 4 integers. So 1000, then 4 into 2 is 8. So 1008 plus j is 0. So in the 1008th location, 5 will be there. So 5 will be printed. Then again, I is 1, j becomes 1. Correct? So again, 4. So again, for the entire, when I equal to 1, this will be 4, right? So PTR plus 4 plus 0, PTR plus 4 plus 1, PTR plus 4 plus 2, PTR plus 4 plus 3. Correct? Then I becomes 2, j varies from 0 to 4. Then what happens? PTR plus 8 plus 0. So PTR plus 8 plus 1 and so on. So this I into C is to move one row. Okay. So I is 0. 0 into C, that's going to be the first row. I is 1. 1 into 4. So I'm moving 4 integers. Now I come to the second row. I is 2. 2 into 4, 8. So I move 8 integers. So I come to the third row. This is what we are doing here. So hope you understand this. Have a great day.